Hello, everyone. So we have another AMC 12 problem. So I guess this was number 17. So we have the sum of the sine A and sine B is given, and then cosine A, cosine B is given, their sum. And based on what we are looking for is just the difference of the A and B's and there's cosine. So if you are familiar with the trig identities, I think this should remind you immediately the angle difference identity for cosine, which is, I'm going to write it first. So cosine A minus B is actually same as cosine A times cosine B. So you just start with cosine of both angles. And whenever you have a minus, you just actually have a plus after that product, and sine A times sine B. Again, this is one of the identities you should keep in mind, especially you need to know how to drive this in the first place. And if you don't, so I highly recommend you to check that out, okay? So that is one of the identities, okay? The question that we have right now is like the sum of these sine A and sine B is given, but it has to be product, right? And we are given the sum again, but we do have the product, not the sum. So maybe we should do something else before we get there. But you know, if you remember the, like if you want to multiply sine A and sine B to get this guy, maybe I can actually square this guy. Let's do that. Okay, so the sine A plus sine B is equal to square root of 5/3. So if I square this, okay, and the left side is the square of binomial, so that would be sine square A plus 2 times sine A times sine B plus the square of the second term, which is sine square B equals 5/3. This is much better because I hope we remember that the sine square A plus sine square B. So if those two angles were the same, then we could get something, but right now we don't really know. What I'm talking is basically this. So we have Pythagorean identity where it says when you square sine of a angle and cosine square of the same angle, if you do that, so that will be equal to 1. And I guess this is the first identity you should be exposed in the trig. So this was the Pythagorean identity. But in order for us to use this, guys, I need to have the angles are the same. But this is A and this is B, which are not the same. Maybe we should do something else before we get there. So what I'm going to try now is the second equation that we are given, right? So the second equation is cosine A plus cosine B equals 1. If you square this equation, okay, so this is also square of binomial, so that will be cosine square A plus 2 times cosine A times cosine B plus square of the second term, which is cosine square B equals 1. So this is the first equation. This is the second equation. So what I'm going to try now, I'm going to add these two. Why I'm going to add these two? Because if I add these two equations, I will get square of the sine square A and cosine square A, which is add up to 1. And then sine square B and cosine square B, which is also another 1. So which is helpful. So let's go ahead and add these guys. Okay, so sine square A plus cosine square, let's actually write in the same order. So plus 2 times sine A sine B plus cosine square A 2 times cosine A times cosine B plus cosine square B equals 5/3 and 1, right? So as I just mentioned, the sine square A, cosine square A is add up to 1. Okay. And also, I think I missed one of them. So I had the sine square B after this term. So let me write that as well. So we had the sine square B after this product. And then we have this guy as the first term. So now if I add this guy sine square B by this guy, that is also another one. And I have 2 times sine A sine B, 2 times cosine A cosine B. So I'm gonna write this guy first because it looks like and then it like start with word. First one with the cosine to make that obvious, but it doesn't really matter, okay? So that is equal to 2 times cosine A cosine B plus this remaining term. So that's 2 times sine A sine B. And equals, like this is a third. Okay, so now we are almost there. So I have 2 right here, right? And then I have 2 copies of the product. Maybe I can pull that too. So cosine A times cosine B and sine A times sine B when I pull that too. And when I subtract 2 from both sides, so that would be 6 over 3 instead of 2. If you subtract from this guy, that will be 2/3. So if you divide both sides by 2, what you want is actually what they are asking for. This whole thing is the same as cosine A minus B. So that's the answer. Cosine A minus B is equal to 2/3 divided by 2 is just 1/3. And that is my final answer. So again, the question wasn't too bad, to be honest, for an AMC like 12 like problem. It's just asking us to use our identities and seeing that actually wasn't too challenging, I assume. But if you don't really recognize that, maybe you should do a little bit more practice about it. Okay. So I hope that is clear. So I'll see you next time.